Now we're going to be doing question 7b, continuing from question 7a regarding our gutter problem. Okay, so the question asks us to find the relationship between r, theta, and w, and then from that find a formula for a so that we can eventually find the derivative, which we need to show that it's equal to w squared cos theta outside of sine theta minus theta cos theta all over 2 theta cubed. Okay, so you might realize that the domain now has changed. It's actually between pi and 0, but that doesn't make any difference because if we notice, if theta starts exceeding the pi on 2 range, the gutter is going to begin to curve upwards from, instead of becoming a semicircle, it's going to actually start turning into a full circle, so that the area actually increases quite a lot. So, without anything being related to that, we're going to now find the relationship between r, theta, and w. So if you realize, as we have a sector of a circle, the arc formula can come in handy, which is L equals r theta. So we replace our L with w, since now w is the length of the arc, and theta now changes to 2 theta, as that's the angle subtended to the circle center. So dividing everything by 2 theta, we're going to get that r is equal to w over 2 theta. Alright, so how is that going to be useful for us? Well, now that we found the formula in part A, that a equals r squared da 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 da, we can now replace r squared with w over 2 theta. And what we get now is an equation for a strictly in terms of theta. So now we can differentiate it. Alright, so if third time's the charm, we're going to get this out now. So we'll begin with dA over d theta. Alright, so instead of doing the quotient rule here, we're going to actually do the product rule because it's a bit easier to do. Okay, so the first term is going to be this little bit here, and the second term is going to be what's inside the bracket. So dA over d theta. We've got the derivative of the first, so this is minus 2w squared over 4 theta cubed times the second, so that's the theta minus sine theta cos theta. Pardon me. Alright, now plus the derivative of the second, so plus derivative of theta with respect to theta is 1, minus, now we've got another product rule here, but it's not too bad because derivative of the first here is cos times cos, that's going to be cos squared, so minus cos squared. And similarly, the derivative of cos is minus sine theta times sine theta, so that's going to be sine squared theta. And times the derivative, times the first. Alright, so now if I simplify this now, we'll get minus w squared theta over 2 theta cubed outside of 1 minus sine theta cos theta. Alright, now we got plus minus 1 cos squared theta minus sine squared theta w squared over 4 theta squared. Alright, so now I'm going to expand the sine squared theta into 1 minus cos squared theta. So this will become minus w squared over 2 theta cubed outside of theta minus sine theta cos theta plus 1 minus cos squared theta minus 1 minus cos squared theta w squared over 4 theta squared. Now if you take a look here, instead of doing it in the next step, you realize that 1 minus 1 and 1 will cancel out, so we take them away. And now the minus and the minus will become a plus. And no, that's not right, sorry. I always forget that. Plus goes there, so we've got minus cos squared theta plus 1 minus cos squared theta. So if you look here, that's 2 of the same thing. So we've got now 2 1 minus cos squared theta, I believe. And that's outside that. Alright, so now I'm going to get a common denominator here because we have the 4 theta squared and we've got the 2 theta cubed. So to make a common denominator here, I'm going to multiply this top and bottom by 2, so we're going to get minus 2 w squared theta minus sine theta cos theta. Now plus, now we just need to multiply this by theta to get the theta cubed at the bottom, so that's just going to be 2 theta 1 minus cos squared theta w squared all over 4 theta cubed. Now let's expand this. So we're going to get minus 2 w squared theta minus 2 w squared sine theta cos theta plus 2 theta w squared minus cos squared theta 2 theta w squared. And take a look here. These two will cancel out, so we cross them off. We'll have the denominator here for theta cubed. And there's a bug here. Got me. Okay, and now we're left with minus 2w squared sine theta cos theta minus 2 theta w squared cos squared theta all over 4 theta cubed. And now taking this back up, now this will simplify too. So if I take out the cos theta now and the w squared, and the 2, I'm going to be left with 2 w squared cos theta. Okay, so if I take that away from this, we're going to be left with minus sine theta. And then taking it away from this, I'm going to be left with 2, we're going to be left with cos theta, theta cos theta. Sorry, I think I made a little error here. Yeah, that should be how it is. Sorry. Alright, now put that all over 4 theta cubed. And then finally, the 2 and the 2 and the 4 will cancel, so we're left with 2 theta cubed. And by surprise, we actually got it. So d alpha over d theta is in fact equal to our result.